Okay, let's talk about portfolio mathematics with matrix algebra. And let's start with a simple example where we have three assets, A, B, and C. And we have the returns of these assets denoted by RA, RB, and RC. And we will be using the notation. The expected return on asset I is denoted by this mu of I, and the variance of asset I is denoted by sigma square I, and the covariance between the asset returns I and J is given by this sigma ij. And since we will invest all our money between these three different assets, we will assume that the sum of our investment weights add up to 1. So in this case, we can write our portfolio return as given in this first equation here, where x indicates the weight of investment in each of these assets. And therefore, the expected return on our portfolio is given by the expected returns on each asset multiplied by the portfolio multiplied by the weights of investment into A, B, and C. And similarly, we can write down the variance of this portfolio by applying the variance formula. And you can see that the investment weights are squared, and we multiply them with the variance of each asset. And then we have the cross covariance terms. And since the covariance of A and B is the same as covariance of B and A, we have this 2 multiplying these terms, and we have 3 possible covariances between AB, AC, and BC. So basically we can utilize the vector notation to represent these portfolio return and variance in a more compact way. So we can write this R as the vector of returns, and our investment weights is simply denoted by this vector X. And then we can actually write down the expected return of each asset in this portfolio by using this vector notation. And here the expectation operator actually is applied to each of the individual asset returns. And these are given by mu A, mu B, and mu C. And simply we can denote this as the vector mu. On the other hand, for the variance, actually, since we have three assets, we are going to have a 3 by 3 covariance matrix. And each entry in this covariance matrix tells us the covariance between assets I and J. And in this case, we have three assets, and the diagonal terms, since the covariance of A and A is same as the variance, and similarly the variance of B and C follows on the diagonal of this covariance matrix. And in simple terms, we can denote this covariance matrix by the sigma square, sigma AB. So these sigma squares are the variance, and sigma AB is the covariance between A and B. And overall, this whole covariance matrix, for simplicity, we can denote it by this capital sigma. Now, we can write the return on the portfolio by multiplying these investment weights times the returns on individual assets that we have. So in the vector notation, this can be simply written as the X transpose times R. And similarly, the expected return on the portfolio can be written as expected return of the investment weights X transpose times the returns of each asset. So this can be written as finally X transpose mu, and basically we know that these are the investment weights and these are the expected return of each asset return. And this is same as writing this as a sum over here. And the variance of the portfolio now can be represented. So notice that this is the variance of the portfolio, and we are looking to the variance of the investment weights X transpose times the returns on each asset. So simply this can be expanded as X transpose. You can notice that this X, which is the investment weights, is pre-multiplying and post-multiplying the covariance matrix sigma. So here we have the covariance matrix, and this is pre and post multiplied by the investment weights to get the variance of the whole portfolio. And also notice that we will need to introduce some constraints when we do the portfolio optimization. And obviously the first constraint is that the sum of our investment weights should be equal to 1. And this can be simply represented by the X transpose times this vector of 1s. And another portfolio with weights, the return on this other portfolio Y can be written as Y transpose R. Now, we need to often compute the covariance between the return on portfolio X and the return on another portfolio Y. So this can be written as the covariance between these two portfolios. And this can easily be done by again using our covariance matrix. And notice that we are pre-multiplying our covariance matrix with the investment weights for the first portfolio. So basically X defines portfolio X and Y defines portfolio Y. And the covariance can be computed by simply multiplying X transpose the covariance matrix times the investment weights for the second portfolio Y. You can see an example, and in this example we have 3 different assets and the returns are given, and also the covariance matrix of these 3 assets is given as this C. So if you want to calculate the portfolio expected return and variance for the equally weighted portfolio, what you can do is you can define your investment weights as 1/3, 1/3, 1/3, since this is an equally weighted portfolio. And then you can calculate the portfolio return by simply multiplying the returns times the investment weights. So that gives us around 10% return per year. And on the other hand, you can calculate the portfolio variance by pre-multiplying and post-multiplying with the investment weights. You have the covariance matrix already given. So if we do this vector operations, what we get at the end is a scalar, and you can take the square of root of this number to get the standard deviation of 26.25%.